Okay, so I'm going to start off by making a little bit of room here for this first one. Pull this down out of the way. So for number one, I'm going to start on each side to see if there's anything I can combine or simplify. On the left side, we have parentheses. There's nothing I can do inside either one of those parentheses, so we're going to see what we can do to them. The first one here is multiplied by 7. So 7 times 2x is 14x. And 7 times negative 5 is a negative 35. Second parentheses is multiplied by negative 2. So negative 2 times 3x, negative 6x. And negative 2 times 1, negative 2. Now before we go to the right side, let's keep going on the left side here and see what we can still combine. We've got 14x and negative 6x makes 8x. Negative 35 and negative 2 makes negative 37. Good. That equals on the left or on the right side, what can we do? Nothing. That's just going to stay 3x plus 13. Now we do still have a variable on each side, so we have to get rid of one. Which one are we going to get rid of? The 3x. It's the smaller one. We're going to subtract it to make it go away. 8x minus 3x is 5x. We still have the minus 37 equals 13. What's next? Add the 37. So 5x equals 50. And finally, perfect. We divide by 5. We get x equals 10. Any questions on that one? You look frustrated. You see how it goes now? Okay. We all have those days. Don't feel bad. Okay, now for this one, because the variables are on the bottom of fractions, or the denominators, we have to find a least common multiple, or least common denominator. So for 6x, 3, and 2x, the number 12 would work, but we could actually just use 6. And then for the variables, remember it's the highest power. So it's just going to be x. 12x would work. We'd get the same answer. So we're going to multiply this whole thing by 6x. So we're going to do 6x times 5 over 6x. So 6x over 1 times 5 over 6x. I can cross cancel the 6x and the 6x. That leaves me with just 5 over 1, or 5. 6x times 2/3. So 6x over 1 times 2 over 3. I could cross cancel the 6 and 3, but it might be easier here just to multiply across. 6x times 2 is 12x. 1 times 3 is 3. And 12x divided by 3 is 4x. Then we're at the equal sign, so that equals 6x times 7 over 2x. So 6x over 1 times 7 over 2x. And here again, I think it might be easiest just to multiply it out. 6x times 7 is 42x. 1 times 2x is 2x. So the x's divide out, and 42 divided by 2 is 21. So now we have an equation that's just a simple equation we can solve. What do we do first? Subtract the 5. So 4x equals 16, and then divide by 4. X equals 4. Any questions? Okay. So today's goal, we're going to be talking about decimals. And most of us are pretty familiar with decimals. Morning. The key to decimals, again, comes down to place values. When we went over place values before, and I'm just going to write these in numerically instead of writing out the words. This is the ones place, the tens place, the hundreds, 1,000s, 10,000s, 100,000s, 1,000,000s, and so on. And as we look at those, anytime we move from one place value to the next one to the right, the numerical value of that place value is divided by 10. 1,000,000 divided by 10 is 100,000. 100,000 divided by 10 is 10,000. 10,000 divided by 10 is 1,000, and so on. 100 divided by 10 is 10. 10 divided by 10 is 1. Well, if we continue to move past the decimal point, and we continue that pattern of every time we move a place value to the right, we divide by 10. Well, 1 divided by 10 is 1/10. Dividing by 10 again is 1/100th. Dividing by 10 again is 1/1000th. And 1/10,000th. And so on. You can see the links here between these place values and these. I get asked all the time, why isn't there a ones place or a once place after the decimal point? And this is why. It's because those place values have to divide by 10 every time you move one spot over. And there is no way to get a 1 on the other side of the decimal point because of that. We might be looking at these place values thinking they look an awful lot like fractions. And that's because that's what they are. A decimal is nothing more than a short way of writing a fraction that has a denominator that's a power of 10. 10, 100, 1,000, and so on. Or expressing it as a fraction with a denominator of a power of 10. So if I have 0.48, that's just a short way of writing the fraction. Now, how would I pronounce that number? I would pronounce it 48 hundredths. That's exactly what it is, a fraction, 48 hundredths. So it's just a short way or an alternative way of expressing that fraction. Now, as a fraction, I wouldn't leave it as 48 over 100. I would reduce it by dividing both of those by 4. I'd get 12/25ths. And it really is that simple to turn a decimal into a fraction. You just take it and you write it out as you would say it, as you would pronounce it. 48 hundredths is 48 over 100. And then reduce. If I have 0.0375, so that is 375 over what? Yeah, that last digit is in the 10,000s place. That's 10,000s. Another shortcut, by the way, to double check yourself. There's 1, 2, 3, 4 decimal places in my decimal. There better be 1, 2, 3, 4 zeros in the denominator of that fraction. Now, of course, I can reduce this. What can both 375 and 10,000 be divided by? 5 will work. 375 divided by 5 is going to be 75. 10,000 divided by 5 is 2,000. What can they still be divided by? 5 again. 75 divided by 5 is 15. 2,000 divided by 5 is 400. And still 5. 15 divided by 5 is 3. 400 divided by 5 is 80. So 3/80ths. What if we have something like 28.528? Well, just like in fractions, we have mixed numbers. In decimals, we have mixed numbers. The 28 here, the part before the decimal point, is the whole number. That will not change. This is going to be 28 and some fraction. So the part that becomes the fraction is the part that's after the decimal point, that 0.528. So to convert that, that's going to be 528 over 1,000. Again, that's the tenths, hundredths, thousandths place is the last place value. Or 1, 2, 3 decimal places, 1, 2, 3 zeros in my denominator. Both of those can be divided by 4, should work. So 528 divided by 4 is 132. 1,000 divided by 4 is 250. Are we done? No, we can still divide by 2. I don't think we can get 4. Let's do 2 first, and if we can get another one, then we'll get it. 132 divided by 2 is 66. 250 divided by 2 is 125. 125 only divides by 5, so we're done there. So it's 28 and 66 over 125.
So just an easier way, like if you have trouble with the place values, just count how many numbers are behind, are behind the decimal point.
Yep.
And then zeros you put.
Exactly. 3 decimal places here, 3 zeros down here in the denominator. Okay. There is a process, like for some of you, if you go into a technical field where you're doing a lot of measurement, if I give you a decimal, like 0.714 inches, and since that's in inches, we're not going to want it as an exact fraction. We're not going to want that as 714 thousandths or 357 500ths. As a measurement, that's not going to help us much. So a lot of times we'll want it maybe to the nearest 16th of an inch. Now, before I go any further with this, shouldn't be in your homework, and it won't be on a test. So just so you know, I'm showing you this as kind of an extra little thing. So if I want that, I've calculated that out to 0.174 inches, but our tooling goes down to the nearest 16th of an inch. So how do I convert that to the nearest 16th of an inch? Well, the easiest way to make anything into a fraction is to put it over 1. Now notice the decimal point is still in there. Right now, this has a denominator of 1. I want it to have a denominator of 16. In a fraction, I change the denominator by multiplying. So 1 times 16 gives me a denominator of 16. If I multiply the bottom of the fraction, I have to multiply the top by the same thing. So 0.714 times 16 is 11.424. What this is telling us is we're over 11 sixteenths. So we're between 11 sixteenths and 12 sixteenths. Which one are we closer to? 11, because it's 11.4. So if we were rounding to the nearest 1, we would round down to 11. So 0.714 inches is closest to 11 sixteenths if we're going to the nearest 16th of an inch. For what we're going to do on our tests and quizzes, though, we will want it exact. So we'll be asked to convert something like 5.36 to a fraction or mixed number. Let me try that in your notes quick. I'll give you a minute to do that. Bless you. So we're going to take the 5, and we're just going to keep the 5. We have to put the 0.36 into a fraction. It's going to be 36 over 100. Both of those can be divided by 2 would work. Somebody back there said 4, which will also work. 36 divided by 4 is 9. 100 divided by 4? 25. And that appears to be it. So 5 and 9/25. If we'd have done 2, we'd have got 18/50 and just one more time and we'd be there. So if we go to do operations with these decimals, let's say we have 8.37 plus 16.9. So when I go to add these, is that going to work? No. What do we have to do? We have to line up the decimal point. So you write the first number, you're going to put the decimal point right below that decimal, then work around that. So 16.9 has to go like that. I'm going to fill in the missing decimals here to just round it out. So I'm going to put a 0 down there. When we add, it isn't necessarily required that we do the 0, but when we subtract, there's going to be a lot of cases where we do have to have it there. So you could put it here. Yeah, you could do that. Now the reason we had to line up that decimal point is, if you recall, when we add or subtract, we can only combine things that have the same name. And that went right down to the individual digits of a number. We can only combine digits that have the same place value. So lining up that decimal point ensures us that we're combining ones with ones, and tenths with tenths, and hundredths with hundredths, and so on. So let's go ahead and do it now. 7 plus 0 is 7. 3 plus 9 is 12. So we keep the 2 and we carry the 1. The decimal point does not affect our carrying at all. But before we add this next column, what should we do? Bring the decimal point straight down. The decimal point, when we add, gets transferred straight down. 1 plus 8 is 9, plus 6, 15. So we keep the 5 and carry the 1. 1 plus 1 is 2. Now the reason this decimal point came straight down is when we add numbers, we keep the same name. So tenths plus tenths, that better stay tenths. So bringing the decimal point straight down kept those tenths. Same here, ones plus ones, that better stay ones. So bringing that decimal point straight down keeps the same name. Subtracting follows pretty much the same rules. We have 52.7 minus 9.84. Just like with addition, we must line up the decimal point. I usually put down the top number, then I put the decimal point down below it, and I fill in from there in the bottom number. And just like with addition, I'm going to fill in that missing space there with a 0. I could put 1 here too if I wanted to. I don't have to. Now it's just like subtracting whole numbers. We're going to ignore the decimal basically as far as our calculation is concerned. 0 minus 4 can't be done, so I'm going to borrow. This will become a 6, and this will be 10. 10 minus 4 is 6. 6 minus 8 can't be done, so I need to borrow again. This will be a 1. This becomes 16. The decimal point does not affect our borrowing at all. 16 minus 8 is 8. Now, the only place the decimal point comes in is right here. Before I go to that next column to subtract, I need to bring it straight down. Just like with addition, that's keeping the same name. The tenths here stay tenths. The ones stay ones. 1 minus 9 can't be done. We borrow, we make that 4, and this is 11. 11 minus 9 is 2, and then we have the 4. Now I do want to show you one more example. Something like this. 8 minus 3.71256. We still have to line up the decimal points. But on the 8, where is the decimal point? At the end. If there is no decimal point written in the number, it is at the end of the number. So 3.71256. And again, we fill in our missing zeros here for our missing place values. Here we go to borrow. 0 minus 6 can't be done. But we go to borrow, and there's nothing to borrow from here. So we need to go all the way to the 8. That's the first place that we find anything that we can borrow from. So we borrow, that becomes a 7. That would make this a 10. Now we do need it here, but we need to get it down here as well. So we have to keep borrowing. So that 10 becomes a 9. This 0 now becomes a 10. I need to keep going. I borrow, this is a 9. This is a 10. And again, that's a 9. Now this is a 10. Borrow again, that's a 9. And this is a 10. And that's where we need to stop. Yeah, a lot of you are taught you cross off the 8, you go 7, then 9, 9, 9, 9, 10. Yeah, that's fine. I just do it step by step so you can see what's the actual process. So now I've got 10 minus 6, 4. 9 minus 5, 4. 9 minus 2, 7. 9 minus 1, 8. 9 minus 7, 2. I bring down the decimal point, and then the 7 minus 3 is 4. Okay. Multiplication. Remember, addition and subtraction, we had to have the same name. That's why we had to line up the decimal point. And then we kept the same name. That's why the decimal point has to come straight down. When we multiply, we do not need the same name. And with fractions, that meant we didn't have to find a common denominator. With decimals, that means we do not have to worry about lining up a decimal point. and then we're going to combine the names. In fractions, that was multiplying the denominators. In decimals, that's going to take on different characteristics depending on whether we're multiplying or dividing. So let's take a look at something like 3.47 times 2.6. I didn't line up the decimal points there. Does that matter? No. When I multiply, I don't need the same name. So that means I don't have to worry about lining up those decimal points. When I multiply now, I am going to completely ignore the decimals until the end. So I'm going to do 6 times 7 is 42, so 2 carry the 4. 6 times 4, 24, plus the 4, 28. So 8 carry the 2. 6 times 3, 18, plus the 2 is 20. So 0, and then we carry over the 2. Before I move over to the 2, just like with whole numbers, I have to fill in a 0 there. I'm also going to put a line up here. So now I've got my 2 times 7, which is 14. So 4, carry the 1. I put it above the line so I know that's a new carry and not from the last digit. So 2 times 4 is 8, plus 1 is 9. 2 times 3 is 6. Now, just like with whole numbers, I'm going to add down the columns here. 2 and 0 is 2. 8 and 4 is 12, so 2 carry the 1. 1 and 9 is 10, so 0 carry the 1. 1 and 2 is 3, plus 6 is 9. Where does my decimal point go? Between which two digits? 9 and the 0. Now you kept saying 3 spaces. How did we know 3 spaces? Perfect. Okay. Perfect. You've been taught that you count the number of decimal places in the problem. 1, 2, and 3. That's how many decimal places you put in your answer. You start at the back and you go 1, 2, and 3. We mentioned way back in January, the reason for that is when we multiply, we combine the names. This here is hundredths. This is tenths. Hundredths times tenths is thousandths. So by counting up those decimal places and putting that many in our answer, what we're really doing is combining the names. Now also, when you look at this, we talked a lot about estimation in the first couple of weeks of the class. 3.47, I'm going to think of that as being approximately 3. 2.6, I'm going to also think of that as being approximately 3. 3 times 3 is 9. My answer better be close to 9. It would not make sense for this to be 0.9022. It would not make sense for this to be 90.22. The only place for that decimal point that does make sense is 9.022. Division with our decimals. I showed you with the whole numbers how the long division process had been really altered through the years to the point where it's not even something we really recognize anymore. I showed you how it really was that repeated subtraction, and we just took a bunch of shortcuts. If I stuck with that old method, the division of decimals is actually a lot simpler than what we do. But most of us have been taught something different. So if we have like 38.276 divided by 2.4. We have been taught not to divide by a decimal. What have we been taught to do? Change this to 24 going into 382.76. You were taught to take that decimal point, move it over to the end of the number. It had to move one spot here, so it has to move one spot there. So that becomes 382.76 divided by 24. The reason we were able to do that, we've mentioned that there is a connection between fractions and division. Is that division problem of 38.276 divided by 2.4 can be thought of as that fraction. And if we want to get rid of the decimal point in the denominator, what we're really doing is, since there's one decimal place, we're multiplying by 10 to make it a 24. Multiply by 10 up here makes it 382.76. Because if we multiply the denominator, we have to multiply the numerator by the same thing. If there were two decimal places here, we would have multiplied by 100 to move it 2 spots. So let's say I want this answer to the nearest thousandth. Let's go ahead and start calculating. So does 24 go into 3? Nope, so we leave it blank above the 3. 24 go into 38? Yeah, it goes in there once. We'll subtract 24. And just like before, we'll subtract. 8 minus 4 is 4. 3 minus 2 is 1. And we'll bring down the next digit, the 2. 24 into 142. It will go, say 6, will 6 go? 6 comes up to 144. 6 just won't quite go. So we'll have to go 5 times. 5 times 24 is 120. We subtract, we get 22. Now this is where we double check, by the way. If we ever subtract and get a number bigger than 24, we know that we could have taken it out one more time. So we have to go back and redo that one. We get 22, so we're okay. Before I can bring down the 7, what do I need to do? Bring up my decimal point. Now I can bring down my 7. 24 into 227 is 9. What is 9 times 24? 216. So I subtract there to get 11. I'll bring down my 6. 24 into 116. It's going to be 4. 5 would be 120, right? So 5 is too much. So 4 times 24 is 96. We subtract to get 20. Now there's nothing left. Does that mean I'm done? No, we can actually add zeros to that. Put a 0 on it and bring it down. 24 into 200 will be 8. 8 times 24 is 192. Leaves us with 8. Now we're at the thousandths place. We wanted to go to the nearest thousandths. Does that mean we can stop? Actually, no. We need to put down one more 0 and bring it down. 24 goes into 80 3 times. 24, we don't really need to do this part. 24 times 3 is 72. There's 8 left. We had to go this one extra digit here. Because to go to the nearest thousandth, we need to know whether this is going to stay as 8 or if it might have to round up to 9. Since this is a 3, 3 is smaller than 5, that's going to stay 15.948. The answer, you're not going to put the 3 on because you want it to the nearest thousandth. If this had been a 5 or higher, then we would have to change this to a 9. That's the only reason we calculated that digit. Nope, you don't need to do a remainder. We're rounding to that nearest place value. Now I realize that Decimals are really easy to do on the calculator, so you can just punch them in. We did converting from a decimal to a fraction. I saved doing the conversion from a fraction to a decimal until we had done this division here. To do a fraction to a decimal, I'll start out with one that most of you know without dividing it out. 3/4 is what is a decimal? 0.75. If you did not know that, however, it's always numerator divided by denominator. 3 divided by 4. If I set that up as a long division, well, 4 does not go into 3. So I put my decimal point in there, and I bring it up, and then I can add a 0. 4 does go into 30 7 times. 7 times 4 is 28. We subtract to get 2. I can add another 0 and bring it down. 4 goes into 25 times. So I get 0.75 or 0.75. We might have 3/7 if I want to convert that into a decimal. Which number goes inside here? 3 divided by the 7. 7 goes into 3 how many times? It doesn't. So we add our decimal point, we bring it up, then we can add a 0. 7 goes into 30 4 times. 7 times 4 is 28. That's 2. Now what? Add a 0 and we bring it down. 7 goes into 20. Twice. That's 14. There's 6 left over. Add a 0, bring it down. 7 goes into 60. 8. 8 times 7 is 56. This is with 4. Add a 0 and bring it down. I didn't say to the nearest thousandth or nearest hundredth or anything here, did I? So let's keep going. 7 times 4, or 7 goes into 40 5 times. That's 35 with 5 left over. Add a 0, bring it down. 7 goes into 50. 7 times. That's 49 with 1 left over. Add a 0, bring it down. 7 goes into 10. Once. 1 times 7 is 7. Subtract to get 3. Add a 0. Bring it down. 7 goes into 30 4 times. Now, at this point, you might see a pattern. 4 times 7 is going to be 28. We had a 3 and we made it into a 30 and we're subtracting 28. That's where we started this. So this next several steps are going to repeat themselves. This is what we call a repeating decimal. If you wanted to, you could go a few more places here to assure yourself that it is going to keep repeating. And it does. Those 6 digits are going to repeat over and over again. 0.428571. 428571. So we can write this like this as 0.428571. And then we put a bar over those digits because those digits repeat. Not all of them turn out quite that neatly. You might have 5/6. When we go out to divide that one, what goes inside? 5 divided by the 6. 6 does not go into 5, so we put a decimal point, add a 0. 6 goes into 50. 8 times. 8 times 6 is 48. That leaves us with 2. Add a 0 and bring it down. 6 goes into 20. 3 times. 3 times 6 is 18. What's left? 2. Add a 0, bring it down. 6 goes into 20. 3. Well, we're stuck in a loop here, right? This one we do have to be careful, though. Would that be my answer? No. The 8 does not repeat. There's just the 3 that repeats. So we put the bar over the 3. Does that make sense? If you don't put the 0 first, it's okay. I believe my math lab picks up on it. On a test, I don't really care. I will say this, in the medical field now, they do require that 0 gets put on there. If it's a repeating decimal, it's pretty obvious that it has to be a decimal because you see the little bar up there. But I made that decimal point pretty pronounced. So let me try this. Is that really 0.8 or is that just an 8 with a stray mark? Well, if the 0 is there, it's pretty obvious that had to be a decimal point. Because you wouldn't put the 0 in front of it unless there was a decimal point there. So if you're going into any of the medical fields, medical assistant, nursing, any of those, in all of their classes, when they start dealing with medications and stuff, they do require that 0 in front of the decimal point. We can use these decimals now in anything that we were able to use whole numbers and integers in. You know, we might have P equals 3.8 D minus M over T, where D equals 4, M equals 6.8, and T equals 1.4. So I'm just going to substitute in here. 3.8, D becomes 3.8 times 4, minus M is 6.8. T is 1.4. Now, of course, we have to do everything on top first. The parentheses I just put in there to signify multiplication, so I didn't confuse a dot for multiplication with a decimal point. 3.8 times 4 is 15.2. Then we have 15.2 minus 6.8, which is 8.4, correct? So then we're back here to having 8.4 divided by 1.4. 8.4 divided by 1.4 is 6. Any questions? Yeah, it's possible. Something like that. So the biggest thing I would say is do this. That's 2.7 plus a negative 4.3. So here we've got a positive 2.7. Negative 4.3 goes the opposite direction and it's longer. So what that's telling us is the answer has to be negative, and it's the difference between their lengths, their magnitudes. So I can just do 4.3 minus 2.7, which is going to give me 1.6. I know it's a negative. Now again, your calculator does do decimals really well. So on something like that, it would do the negative for you. Yeah. That's why I use this picture, because this picture tells me they're going opposite directions, so I'm going to subtract the values instead of adding them. And I end up on the negative side, so I know my answer is negative. Yeah. There is a quiz that is due tomorrow. That's Thursday at 11:59 p.m. There's new homework That is due for Monday. Those of you who got your email from Blackboard, tomorrow they are doing the community college survey of student satisfaction or whatever. They'll be doing that during this class, and you may take it in other classes as well. They randomly select classes every semester to do that. This one was the lucky one this year. So they will be in here tomorrow. There will be a sign-up sheet when you come in the door to sign up. You will get 5 points for being here tomorrow and participating in the survey. I won't be in the room for that. Someone from Shell 8 comes down and administers that survey. So you'll be in their hands. The good news is they'll probably get done. It probably won't take the whole 45 minutes to do it. It'll probably be 25 or 30 minutes is all it'll take. But please be here for that because that's very important for the college to get that information.